Good morning, student. Today we are going to revise chapter 1, that is matter, and in which we are going to first discuss about density. Now you see, density means what? It is a very important characteristic property of matter. So when one speaks of lead is a metal, as being heavy or aluminium as light, one is actually referring to the density of these metals. So density is basically defined as mass per unit volume. Now you see that densities for solids are reported in grams per cubic centimeter, and densities for liquids are usually expressed in grams per milliliter. See, 1 milliliter of liquid takes up the same space as 1 centimeter cube. So, the density for a liquid in grams per milliliter could also be reported as grams per cubic centimeter. For gases, the densities are reported in grams per liter. Now, as you can see here in this example of density, if volume of two different substances like low density, suppose low density is A and high density is B. There are two objects. But as you can see here, the mass of B is greater than the mass of A. Then density of B is greater than the density of A. Density of B is greater than the density of A, this one. So every substance has a unique density, and this characteristic physical property can be used to help identify a substance. So now I think it is easily understood that what is the meaning of density and which is higher density and which is low density. As you can see, the molecules are very closed, so it is highly dense, and where the molecules are far, they are low dense. One more example I want to show, like you can see here that density of matter is what? That how tightly packed matter is. So the amount of mass in a given space decides the density of matter. So as you can see here, that solid, liquid and gas particles, which is highly dense, which has more dense, so solids more dense. Why? Because the particles are very closed. The amount of mass in a given space is more, so that is why solid is more dense, okay, than liquid and then gas. So on the basis of particles, closeness of particles, you can easily decide the density of matter. So now you can solve question number 1 from your assignment. So do that. Now let's discuss law of conservation of mass. So a French scientist named Antoine Lavoisier, who is also known as the father of modern chemistry, gave a very law of conservation of mass. Here what he proved is that the mass of product in a chemical reaction is equal to the mass of reactants, and he named this law of conservation of mass. So what he said, that you can see that law of conservation of mass here, that mass is neither created nor destroyed in any chemical reaction or in ordinary chemical and physical changes. So it must start and end with the same amount. For example, you can see that some logs are here, and if you fire these logs, 30 kg log is there, and 1 kg fire means 1 kg fire means what? 1 kg of heat we supplied to log. That means here always remember that any chemical reaction follow this law of conservation of mass. That means total mass of reactant should be equal to total mass of product. So if you take 30 kg of log and if you supply heat to it, 1 kg heat, then what happen? It converts into ashes and smoke. So as you can see here in example, that total mass of reactant, that is 30 plus 1, 31 kg, and what is the mass of product? 28 plus 3, that is 31. So here it obeys this law. That means total mass of reactant is equal to total mass of product, that is equal to 31 kg. So here it obeys law of conservation of mass. Now again you see this law. One more example. Suppose I'm taking methane. Okay, I'm taking methane and we burn this methane. So every time if we burn, it burns in presence of oxygen. So you can see here CH4 plus O2 gives out CO2 plus H2O, means carbon dioxide, and water it gives. So first of all you have to balance. Okay, why you have to balance? You have to balance because in order to obey this law, because mass can neither be created nor destroyed. If you cannot balance the equation, that means somewhere mass is created and somewhere it destroyed. But you have to show in the whole process that it is neither created nor being destroyed. So if we burn methane, it gives carbon dioxide and water. So methane 12 gram, carbon. So mass number of carbon is 12, hydrogen 1, oxygen 16. Okay, so 12 plus 4 into 1, that is 12 plus 4 is equal to 16 gram. Oxygen 16, right? So 16 into 2, how much? 32. Right, and 2 moles of O2 is present, so that is why 2 into 32 gram. So here total mass of reactant is how much? 16 plus 32 into 2 is equal to 80 gram. Then what products it gives? Carbon dioxide and water. So carbon is having mass number 12 gram. So 12 plus 16 into 2, 32 plus 12, that is 44 gram. What about water? So H2O, 2 into 1, that is 2 plus 16, 18, and 2 moles is present, so 2 into 18. So total mass of product is how much? 80 gram. So as you can see here, the total mass of reactant is equal to total mass of product. That means it also obey law of conservation of mass. So if any numerical will come that explain this reaction with the help of law of conservation of mass, first of all what you have to do, you have to balance the chemical equation. Then the masses will be given in the question. You have to add on the masses of reactants and products separately, and then you have to show that reactant mass is equal to product mass, and hence it obey law of conservation of mass. So this is all about law of conservation of mass. So question number 3, you're going to solve like this only. What is the question? In a reaction, 5.3 gram of sodium carbonate. This question number 3. 5.3 gram of sodium carbonate reacted with 6 gram of ethanoic acid. The products were 2.2 gram of carbon dioxide, 0.9 gram of water, and 8.2 gram of sodium ethanoate. Show that these observations are in agreement with law of conservation of mass. So how you're going to solve this one? As you can see here, 5.3 gram of sodium carbonate plus 6 gram of ethanoic acid. So if you add on these two reactants, you will get 11.3 gram. Right? Then the products were CO2, which is 2.2 gram, H2O 0.9 gram, and sodium ethanoate 8.2 gram. So these products are being formed by the two reactants. So now you add on the product 2.2 plus 8.2 plus 0.9. So you will get here also 11.3. Right? So now you can write that total mass of reactant is equal to total mass of product. Hence it obey law of conservation of mass. Okay. First of all, you have to check that here you don't have to check that the reaction, chemical reaction is balanced or not, because the masses is being given in the question, that the masses whichever it takes, it is given in the question. So that is why you don't have to balance the equation. But again, in order to follow this law where the masses is not being given, then you have to balance the equation. So here also you check once that the equation is balanced or not. If it is not balanced, then balance it, and then the masses are given only, so according to this you just solve the question. Okay, and where the masses will not be given, there they will give you the mass number of the substances, like of the elements, like sodium, carbon, oxygen, like this. Okay, so like this you solve. Thank you.